Right, so in this function here, we need to check if the serial port is available, right? If they add data in the serial buffer or the serial stream. Now, because we're going to use a serial begin connection here, it's important that we include a delay here just so that we avoid problem. So I'm going to add a delay function just to make sure that we give some time to allow connections into our serial communication. And then into my Raspberry Pi control, so I'm going to basically just add the if statement, right? An if statement that's going to check whether there are serial data available. Okay, so to do that is if serial, right, that available. Okay, now if this serial data available function is greater than 0, that means there are data available into the serial port. Okay, then what we're going to do is to just take that message, okay, take that message that is coming from the serial, and we need to read it until we reach the end of line. Okay, so that will mean we have read the whole message, so we store it. Okay, I've explained this on the previous tutorial, but before we do that, we have to create a variable. A variable must be of type string. So I'm going to just say message from Pi. Okay, so this is a message from Pi, and the message from Pi is serial that read string. Okay, until. Okay, so we're going to read the string until we reach the end of line, so that basically we're not going to miss anything. And then we need to add the end of line character, right, like that. Then we have our semicolon there so that we avoid problems. Okay, so now we've got our message that is coming from the serial stream, and we are confident that we are catching this message. So which means the next thing we need to do here is basically to process it. Now we can process it. In the previous tutorial, we can display the message onto the LCD. Okay, but we don't have to do that now. If you want to see how we implemented it, please watch the previous tutorials. Right, now the simplest way to handle data from the serial stream here is to implement an if-else ladder. So I'm going to create another if statement here. So we're going to say if, right, msg pi is equal to green. Okay, so if the message is equal to green, then we want to basically toggle the green LED. And we know that in order for us to turn the green LED, we need certain variable here must be. So obviously red and blue must be low, and this must be high. So what I'm going to do here, I'm going to take this digital control function here. I'm going to modify this digital control function so that it can take some parameters. So the parameters that we need to pass here, they must correspond to these high and low variables. So basically these parameters, they are of type unsigned int 8-bit underscore t, and we're going to say red, the first one, then unsigned int 8 underscore t blue, unsigned int 8 underscore t, and green. So now we can go ahead and replace the green pin with green, the red pin with red, and the blue pin with blue. Okay, now we are not done yet here. The next thing here, okay, there is a small typo here, very important. Okay, now the next thing here is to basically call this digital control function. So if I come here and then say digital control, and I need to pass parameters. So what parameters I want to pass? Let's say we've got red, blue, green. So I can say, I'm gonna say red, R, B, blue, and then green. But now these variables, I will need to define them here. So in a case where the command is to turn the green LED, then I know that the green pin here, or green, must be high and the rest must be low. So I can just say G is equal to high and R is equal to low, and blue is also equal to low. But G, R, and blue, they are not defined yet, so I have to define them here. Okay, and also the MSG pi is also not declared, so I need to do my variable declaration. MSG pi is basically a string. Okay, so this is a string variable, so string MSG pi. Okay, then we need u int 8 underscore t, which is an unsigned 8-bit integer, so that's going to be RGB. Right, so this is basically all we need here. Let me just give this a spin and see if we're going to have problem. Okay, there are no problems. Apparently the code just ran peacefully. So now if we can give this a test, so that basically by calling the serial monitor, okay, then let's enter green. So if we enter green, we should get a green color. Okay, we're not getting anything. Why are we not getting anything? Okay, obviously because we are still running the analog control. So I must write this into the Arduino and we can give it a spin or a test if you want. Okay, so let's now go ahead. You can see now there is obviously nothing running in there. So if I say green, okay, so it's case sensitive, green, then we have a green color. Okay, so I say red, we're not going to get a red because we do not have red yet. So we need another else if here. So else if, okay, MSG pi, okay, MSG pi is equal to what? Red, and then what do we do? So we basically can just copy all of these again here. Okay, so we can copy all of these. So this time around it's for red, so this is going to go low and this is going to go high. Okay, and the rest will remain low. Now let's go ahead and add another one. Else if MSG pi, the message from pi is equal to blue. Okay, and what we're going to do is also to just paste, and this time around green is obviously gonna be low again, red is gonna be low, and only blue is going to be high. Okay, so now I can auto format, compile, there is no problem. Now we can upload. Okay, the code have been uploaded. Now serial monitor, now we can check for red and we're getting a red color. For blue, we're getting a blue color, green once more, and we're getting a green color. So this is obviously, it's not as difficult to implement. It's a very simple implementation. So this is working. Now the next stage here is obviously to now implement this code, because the Arduino is now ready to receive commands. As we have demonstrated, the Arduino can receive commands. So now the command need to come from the Raspberry Pi. Now the current Python script was actually implemented already to be able to transmit data from the Raspberry Pi to the Arduino. As we can see, this send data function was designed to let the user select either a on or off, and that is going to be transmitted, and the Arduino should be able to handle it. Now, this current application here, the Arduino is expecting instruction in the form of green, red, blue to turn on a green or red or blue light, right? So let's go ahead and give this a try. Let's just see if this the send data, okay, send data function is actually being used here. So I'm going to go ahead and give this a run. Okay, there we go. Arduino connected. Now we need to select either on and off, but we know that if I select the on, nothing is going to happen because my Arduino is expecting either a green, red, and blue. So let's go ahead and select blue and see what's going to happen. Okay, there we go. So it is working. Indeed, it is working. So what I'm going to do here is, because we want to make like some form of a simulation here, because we know that all the colors are working, red is working, and obviously green will also work. So the application is already almost operational. But because I want to simulate some kind of a traffic signal, right? So that means I want the red, the green as is now to stay on for like 15 seconds or 10 seconds. After that, we need to have the amber color for 3 seconds. And after that, we get a red for another 15 seconds. So that's like simulating a traffic signal, right? So which means I need to come to this send data function and do some modification, obviously just including an if statement here that will be able to execute after 10 seconds or 3 seconds respectively. Now also then, because we do not have amber here, we've got a blue color, so we'll have to add another option here for the amber color. Okay, so I'm sure, because we know that if we mix red and green, we're gonna get the orange or yellow color. But because amber is slightly there is more red than green into it, so which means it's orange. So I'm sure we will have to use the analog write rather than the digital write. So analog write then will control the intensity of the red and green so that we can get amber color. Okay, but before we get there, let's first modify this function here so that we will be able to actually execute after 10, 15, 3 seconds, as I have said earlier. So to do that, the first thing here is to obviously add a variable, right? That is going to be like a counter variable. So I'm gonna call this wet, and let's just initialize this wet variable to be equal to 0. Now we've got already a time that sleep inside this while loop here, so which basically means every second something is being delayed. So I can just go ahead and just increment my wait variable here. So I will increment it by 1. Okay, just like that. So wait will be incremented by 1 every second. Okay, so then let me then go ahead here and add an if statement. So I'm gonna first say if wait, right, is equal to 10. So if wait is equal to 10, what do I want to do? I want to send the green instruction. So data must be equal to green, right? So let's put the green, and to complete our instruction we need to add the end of line here, so the new line character. So I'm going to just go ahead and copy here, okay, and paste like that. Okay, that is perfect, because here in the Arduino side we are reading the serial string until we reach the end of line. So if we do not add it, we will not know if the message have been completely sent. Okay, so now what we can do here basically is just to copy here. So I'm going to copy this as data, right, and I will just paste it here, right, because I'm just going to be sending that. Now I'm going to then just comment out this section here. Let's comment it out because we do not need it again. Now right now, if it is already green, okay, it is already green, so let me change it to red and then we test it, because what will happen here is that the light is going to turn red after 10 seconds. You can see the Arduino is already connected. We are waiting for the 10 seconds. I think I should probably display the 10 second. There we go. After 10 seconds, it have turned to red. So maybe we need to display via a print statement here. Okay, I think it is important we display it via the print statement. What is the current value? Okay, so this must just change. So weight, okay, is equal to, now this is not going to be data, so this is going to be just weight. Okay, like that. And then after writing, we then need to reset the weight. Okay, after writing, weight must then be reset to be equal to 0, and the loop is going to continue. So let me change this back to put it to green. Okay, stop and run. Okay, now we should be getting some form of a counter. Whoa, there is something that just threw an exception here. Let's have a look. It says can only concatenate string to int. Okay, yeah, because this is a string and this is an integer, so which means I need to do some form of a casting here. So I need to do some form of a casting like that. Then the problem should be able to go away. I don't know what I just clicked there, but let's give it a try again. Okay, there we go. So now we can see the weight variable is incrementing, and when weight reached the value of 10, then we can see that the green light is coming on and weight have been reset again to 0, so it's starting again. And after that, it's going to turn green again because that's the only thing we have. So we can go ahead and continue our implementation here. I can just take this out. Okay, now as you've seen that currently the green LED is only coming on after 10 seconds. However, we would like the green LED to comes on immediately or instantly as soon as we hit a run button. So which means I have to change this here if weight is equal to 0 rather than 10. Then I need to move the increment here after the if statement. So I'm going to just place this right here. Okay, now let's go ahead and give this a run. You'll see that as soon as the Arduino is connected, we already have the green LED that is already on. Now what we want to do is then to wait after 10 seconds, and after 10 seconds we would like to now turn the amber LED right on. Okay, so what we're going to do here is to basically add another else if statement here. Okay, and in Python it's not an else if, it's an elif, right? So we're going to say elif emb. Okay, so I'm going to introduce another variable. Emb is equal to 1 and weight is equal to 10. I would like to now at this point here turn the amber LED on, right? So I'm going to just copy and paste here. Right, we do not have amber right now, so I'm going to put here blue. Okay, we would like to turn the blue LED on after 10 seconds. But wait, okay, there is still something here. So this is a new variable, so we need to first add that variable definition, otherwise we're going to get an error. Okay, m is equal to 0, but we are waiting for m to be equal to 1 before we can turn this on, right? So the ember, so which means we need to after the green LED have been turned on, we need to change the variable ember from 0 to 1. So we can do it here. So m equal to 1, right? So after m is equal to 1, this elif statement will only execute when the wait variable is equal to 10. Okay, so let's give this a try and see if we are indeed getting somewhere. So we start. As soon as the Arduino is connected, then we have the green LEDs, the green traffic light. Then we're going to wait for 10 seconds. After 10 seconds, we should have the blue LED. Okay, so in this case, this should be our amber light coming on. Then what we need to do here is we need to reset. Okay, we need to reset the wait variable just as we've done here. So wait variable is then equal to 0. So we've now reset the wait variable. Now, after that, okay, so this is only going to stay amber or blue for 3 seconds, okay? Let's say it's just going to stay for 3 seconds. Then we need another elif statement here where we then going to turn the red LED. So this means we need to introduce a new variable, okay? A new variable that will be called red. So elif red is equal to 1, okay, and right, wait variable, okay, wait variable is equal to 3, okay. Then in this case here, we then need to turn the red LED on. So I'm just going to copy paste here and change these to red. But okay, we still need to redeclare or define the variable red here and initialize it to be equal to 0, okay? And at the same time, we have to reinitialize it and assign the value of 1, because otherwise this will not execute here. We are resetting wait to be equal to 0, but we also need to set red to be equal to 1, because red is already equal to 0 there. So we need to set red to be equal to 1. Okay, so let's stop this and give it a try again. See if we're going to get a red traffic signal. Oops, there is something wrong on our script. Red is okay, we need a double equal sign. Okay, if red is equal to 1, right, because we are making red 1 here, not red wine like a drinking beverage. No, we're making red equal to 1. Then we're checking if red is equal to 1 and wait is equal to 3, because we are resetting wait here after turning blue. Then we should be able to get the red color. And after that, we should be able to reset, okay? Because after that, then we must turn green again, so that the cycle must continue. But let's give this a try and see what we're going to get. Okay, so we got green. Then we're waiting for our 10 seconds to elapse. Okay, so after 10 seconds elapse, then we have amber, blue at this stage, and after 3 seconds, then we've got red. Now, after 10 seconds, we are getting only blue, we're not getting green again. Now the reason we're not getting green, because green is only active is wait is equal to 0. Now we need to reset wait here. The only place we're resetting wait is here, so we also need to reset the wait variable to be equal to 0 here. But if the wait variable is equal to 0, then we're going to get back to the green. So let's stop this and give it a run again and see if we're going to get somewhere. Okay, We coming 8 seconds, 9 seconds. Okay, amber. Right after 3 seconds, then we got red, and oops, after 3 seconds we are remaining on red. So we not, because amber need to be equal to 1 in order for that to execute. So here we need another variable. So we need to set green to be equal to 0. So green must be equal to 0. So which means we need another variable, must be called green here. So green equal to 0. Okay, here we're going to say and green is equal to 0. But after that we must set green to be equal to 1, right? So green must be equal to 1. Then green will only be equal to 0 when we come to the red one. Right, so let's go ahead and give this a try again. Okay, we have green, that's correct. Okay, so white is 0, green is 0, that's fine. Then after 10 seconds we getting blue, we getting amber. After 3 seconds we getting red. Then after, oops, so we are basically stuck into this traffic signal. So the traffic is red, so this is going to cause a traffic jam. So we need to call some traffic technicians to come and resolve this problem. How do we get out of the red signal here? Because this, okay, so this is executed when red is equal to 1. So we basically need to put red to be equal to 0. Okay, so when we put red is equal to 0, then we will not execute it again. The only time we're going to get red to be equal to 1 is when we execute amber, okay, or the blue. That's when after that we're going to get red is equal to 1 again, and then we'll execute the red. So let's give this a try and see whether we have indeed resolved our problem. So we have a green LEDs going on here, green traffic light I should say, and after that we have a blue traffic light, we got the amber. Then after 3 seconds we've got a red traffic signal. Then after 10 seconds, or what is going to happen here, now we can see that, okay, after 10 seconds we went into amber, then we came back again. So we were supposed to go back to the green LED or the green traffic signal. So how are we going to solve these? We need to so the first statement here, in order to execute, we don't wait. Basically wait must be equal to 0, so instantly. So what must happen here, since we are resetting the wait variable to be equal to 0 here on the red traffic signal, now we need to wait for 10 seconds, right? How do we wait for 10 seconds? Now in order to wait for 10 seconds, we need to set, right, this to be equal to 10. So this must only execute after 10 seconds of executing this one. So the trick would be basically to initialize this to be equal to 10. But wait is initialized to 0. We don't want to wait for 10 seconds to start green, so we can basically just initialize the wait variable to also be equal to 10. That way instantly we're going to execute this, and after executing this we execute that, and we execute the red traffic signal. Then after executing the red traffic signal, since we've set wait to be equal to 0, then we're incrementing here, we only going to go back to green when wait become equal to 10. Okay, but from this get-go it will execute instantly because we have set it to be equal to 10 here. So let me stop and let's try again one more time. Okay, we are going 4 seconds, 5 seconds, 6, 7, 8, 9, 10. Then we have the blue light or amber. After 3 seconds, then we've got a red robot, red traffic signal. Now at this point we are waiting for wait to be equal to 10 before we execute. After that, we execute green. Then after 10 seconds, okay, so we waiting on green for 10 seconds, then we go to amber. There we go to blue, and after that we go into red, okay, after 3 seconds, and after that we go back to green. So it seems like this is indeed working. So I'm going to basically, what I'm going to do here, I'm going to print what we are going to be sending. So let me just put data here. Okay, so we basically printing data. Okay, so it says signal is equal to what we are basically sending, and I'm going to paste the same thing here and the same thing here. Let's go ahead and see whether we are able to basically print. Okay, signal is green. That's correct. The signal is green. Then we go again. The signal is blue. The signal is indeed blue. Then the signal is red. Then the signal is red. The signal is red. We are waiting. After 10 seconds, the signal is green again. So our code seems to be working now. The only issue we have here is to change the Arduino code so that we can get an amber. To resolve that, I'm just going to put an else if statement. So I'm gonna leave the blue in there, it's fine. I'm just going to include another else if statement here, and the message inside must then change to amber. Okay, so this is going to change to amber, and then we need to execute amber here. So in order to execute amber, we need the analog write. So I will not take this analog control program. I will basically just copy all of this, okay, and then paste them here. Okay, auto format. Then we know in order to get the orange, which is amber, we need to have red and green with different intensity. So I'm going to, let's first try 180. Okay, let's try 180 on red, and let's try about 50 on green, and 0 on the blue LEDs. Okay, but we then need to write this into our Arduino and see whether it's going to work. Okay, so then I'm going to just basically change this statement here to amber. Right, so the code is uploaded. We've changed it to amber. Let's give it a spin and we see what we're going to get. So we got green. Okay, green signal. Then the traffic is rolling. Then boom, amber. Okay, we got some form of an amber, and after that we have a red traffic signal. Okay, so this amber is actually quite very fast. Let's just put it like 4 seconds, and so we can it seems like we're actually getting the amber by giving a 180 and a 50. So the intensity of red is dominant and a little bit of green, and it indeed does give us the amber LEDs. Right, there we go, and we go to red. So this is it, guys, for this tutorial. I hope it has been very useful, and if you find it very useful, please indeed give this tutorial a thumbs up and subscribe to CMTEQ channel. Until next time, stay tuned for more upcoming tutorial on Arduino and Raspberry Pi interfacing. Until next time, cheers.